Bismillah ar-Rahman ar-Rahim. Okay, so we started having a look at refactoring on Thursday, and uh, today, inshallah ta'ala, we'll try to make it, we'll try to understand in more details. And what we said on Thursday was that, ultimate aim or objective of refactoring is that you want to improve overall existing design and subsequently your source code. And we're looking for, in a very ideal scenario, we're looking for like a button on a keyboard where we basically just press it, refactor, and everything is refactored. This is an ultimate objective, but of course we haven't reached that stage yet. We have not, technologically or technically, we haven't reached that stage that we can just, say, write a piece of code and, press a button and it just refactors it in a correct way. Of course, we have a lot of automation now, and I'll talk about this very shortly. But as an ultimate objective to improve the existing design by just pressing a button or tick in a sense, it doesn't really work at this stage. But we have made a lot of progress towards that. So as on Thursday we talked about what's refactoring. We tried to understand what's refactoring. So we kind of, went through the different definitions. I'll use this as a starting point, the main definition as a starting point today as well. But later on, we'll look at why refactoring, So if once we understand what's the refactoring, we need to understand why we need to do refactoring. We'll look at some examples of refactoring, as we move along. We'll see, if we can come to this stage today or for sure, inshallah, on Tuesday. And we'll look at these code bad smells within across classes. And at the end, we'll look at some of the obstacles we face when doing refactoring. But let's focus more on this part today, which is why we need to do refactoring. So, yeah, let's come to this definition. This is a good starting point for us. So as Martin Flower, he said that refactoring is what? Refactoring is all about making sure that you go on and change a piece of code in such a way that it does not alter the external behavior of the code, but you improve the internal structure. And this is the whole concept of refactoring, that I should be going on and trying to improve the internal structure of a piece of code while making sure that my external behavior has not changed. And of course, as we discussed on Thursday, this is not an easy thing to do, how to ensure it. And this is where the challenge is. And one of the very obvious technique we use to ensure this and make sure that once we have done the changes internally to the piece of code, our external behavior has not changed, is via testing. So testing plays a very, very important role here, that we need to test our applications after refactoring to ensure that it has not changed. And of course, how we do this is, of course, there are certain tools as well. As I said, we haven't reached a stage where we press a button and it does everything perfectly, but lot of tools are there as well which helps us do these refactoring and somehow tries to ensure more formally through code analysis that the external behavior has not changed. But primarily we still use testing. Mainly we still use testing. And how we ensure this? Of course, you guys have not done the testing course yet, but based on your basic understanding of testing, how we will be ensuring this?
I think test it in the same, like in the same context as the same context before refactoring.
But how I will know that my external behavior has not changed when I do testing?
Doctor?
Yes.
I compared.
Yes, go ahead, sir.
I think we tested, like we tested before the factoring. I tested before after the refactoring, and to compare both of them.
Both. So compare what exactly? This is my question. What compare what?
The results.
The results. Yes. Yes. Yes, Abdullah.
Yes, I think we can ensure this by using the same test cases. If we
True.
use the same test cases, and we get the same results. Yes.
Yeah. So basically, just because we need to, again, it's not a testing course, but I'll just give you a bit of idea here. Like, it's a very basic idea that, when you have test cases and when you execute them, you basically, have something called expected output, right? And then you have something called actual output. Now, when you say that my test case has passed, that your expected output is same as your actual output, correct?
Correct.
Yes. And then, as part of the refactoring process, first of all, you apply this test case on your original code, right? And of course, you make sure that your expected output is equal to actual output. So it worked fine, it achieves the target, it does what it's supposed to be doing. And when you do the refactoring and you've done the refactoring and now you have a refactored code, you need to go on and execute the same test case again and make sure again that the results, the expected output and the actual output are still the same. And if it's still the same, it means you have preserved or you have not changed the external behavior of the code. Of course, as part of this refactoring, you have internally restructured the piece of code. Right, so this is what the whole idea is in refactoring, and that's why you will see that refactoring testing go hand in hand. And I'll talk about this very shortly in more detail as well. I mean, not going into testing part of it, but as a concept. So what's refactoring? At the end of the day, refactoring is all about cleaning up the code after it has been written. It's a very important point to understand that refactoring is something you do once the code has been written. And if you don't have a working code, there is no such thing as refactoring, or there's no need to do any refactoring because that's meaningless. So you've got to have a code which has been tested, and then you do this activity, what we call refactoring, to clean up the code. And of course, the whole idea behind refactoring is that, we're looking for certain potential problem areas, what we call technically code bad smells. And as we saw, for example, during our architecture, that there are so many architectural styles which have been people have tried over the years in the industry, and as a result, now we know that we don't have to reinvent the wheel. They have for example, client server or event based. So these styles are there. Similarly, when we came to solid principles, again, we know that people over the years have tried different things and they came up with these rules for us that, you should have single responsibility and so on and so forth. And then we also went through the design patterns. And again, we don't have to reinvent the wheel. We know that now that over the years, people have tried these different structural and creational and behavioral patterns. And, given our context, we can use it. So similarly, here, even in the refactoring, people have, try to identify potential problem areas that can be there in your piece of code. And then basically once we know this, again, we don't have to reinvent the wheel. We know these code bad smells. We need to just make sure that we try to avoid it by removing these code bad smells as part of the refactoring. Now how? Inshallah, I'll show you some examples later, probably on Tuesday, but this is what the whole idea is. Any questions on this so far?
No, thank you.
Great. Now my question is, are these code bad smells bugs in the system?
No, not bugs.
They are not bugs, right? And the reason we know they are not bugs is because, for us to do refactoring, system must has been written and tested. Okay. So it means once your test cases have passed, it means, that it's actually doing the functionality it's supposed to be doing. So code bad smells are not really bugs as such, but they are potential problem areas which can lead to bugs. That's the point. That if you don't fix those problems, it can lead to bugs. For example, by introducing misunderstanding or by having so many things happening in one method, for example, that you are bound to make mistakes, so on and so forth. So there are potential problem areas, and as part of the refactoring, we are targeting these potential problem areas, trying to remove them to best of our abilities. Everybody is on board with me on this point, right? Because this is a very key point to understand. I think so. Okay. So, and not surprisingly, again, refactoring is integrated very much into agile development. Uh, of course, it is used in other processes as well, but when it comes to agile, refactoring go hand in hand because, again, as you know, in agile, you basically write piece of code from day one. For example, you're using Scrum, you have your different sprints going on, right? You write piece of code, you test it, and then you refactor it to improve its overall structure, try to remove these potential problem areas, and so that you are ready for the next iteration or next sprint in your agile. So that's why you will find if you're doing agile, by the way, which is very popular out there in the market, so you're doing agile, you'll be doing a lot of refactoring, and that's why refactoring is very, very important for us to understand as designers. At the end of the day, I'm pretty sure maybe you guys have seen this statement somewhere. At the end of the day, it's a bit harsher by Martin Flower, but it makes sense. Have a read of what he said. We are trying to write at the end of the day. See, the compilers, the computers will follow the instructions you give it to it. So as long as you're syntactically correct, and logically you are not making any mistake, the program will do the job, right? Because it will understand instructions. But ultimately, what we're trying to do is we are basically trying to become good programmers slash designers because we write a piece of code and we design in such a way that the humans can understand. That's the ultimate aim, and that's what we do refactoring for, is that we try to restructure in such a way that it's a bit easier for us to understand. It's a bit easier for us to process the information and write stuff in more clearer way. Now, typically, we can understand this in more detail with the help of these, three hats example. So basically, we have three hats, and one hat is for coding. And as part of the coding hat, basically, your responsibility is to add capabilities or new functionalities to the system. And when you put the hat of a tester, your responsibility is to perform test cases and make more test cases and carry on these test cases. While when you do refactoring, basically you're trying to restructure the code, all right? And when you're trying to restructure the code, very important point here is we do not try to add new features or new functionalities as part of the refactoring process. And we do not try to add new test cases. Yes, we can modify some of those test cases, but we don't try to add new test cases. And in a given agile environment, you may be at a certain time during your sprint, maybe doing coding, and you might be at the same as the same person at another certain time could be doing testing, and maybe you will end up doing refactoring as well. You can swap your hats at a given time. You can be at coding, you can be doing the responsibility of a coding or doing the responsibility of a testing or refactoring at a given time. You can change these hats, but at a given time, you only wear one of them. Is this point clear to everyone?
Yes, it's clear.
Yes, great. So basically, in a typical agile environment, an agile team, you might be doing coding, later you'll be doing testing, you'll be doing refactoring. Now, uh, I believe this is clear at least. You do not add new features as part of the refactoring process. Why? Is this clear, right? We don't do add new features. Because if you have to add new features, what exactly you're actually doing? Or which hat you
Coding.
have on?
Coding.
The coding hat, exactly. So if you're adding new features, uh, you know, uh, even if you're debugging, right, uh, or solving some issues, basically you're putting the hat of the coder. Now, what about this one? You're not supposed to add new test cases. Why is that?
Because
Because you're
this
not
is
tester at this point.
One by one, please. Yes, Turkey?
Because you're not tester at this point.
You're not tester at this point, yeah. Any other reason why we're not supposed to add new test cases? Or let me ask this another way. What will be the scenario where you will have to add new test cases? In which situations you will have to add new test cases?
Doctor,
Yes, Abdullah?
I think when the coder adds a new capability to the system, the
Correct.
tester adds new test cases to the system.
Correct. So basically, and in a refactoring stage, we are not supposed to add new test cases because here we're not adding new functionalities anyway, right? And typically we add new test cases uh, when you were adding new functionalities, or we add new test cases. There is another situation when we add test cases where the existing test cases are not good enough for us to give us confidence that there are no bugs in the code. And then, of course, that's the responsibility of the testing hat to add new test cases, right? So just be clear about this, that you put different hats at a given time. You'll be only putting one of them, or you will be wearing only one of these hats. When you're wearing the refactoring hat, you are only changing or restructuring the code. That's all you're trying to do. You are not supposed to be adding new functionalities. You're not supposed to be adding new test cases. You need to restructure it, run these test cases, the existing test cases, make sure you have not changed the external behavior. Cool.
cool.
Alhamdulillah. Perfect. Now, of course, we have different refactoring methods. We have different ways of doing it. So basically, refactoring methods, or simply we call them refactoring, are some basic principles, best practices uh, for basically, of changing the code to improve its understandability, maintainability, scalability, and so on and so forth. So we have these best practices like design patterns, like architectural styles. We have a set of best practices which we know over the years from the industry that they are potential problem areas, and we should not have these kind of potential problem areas because they lead us to problems in the future. So again, we do refactoring to improve or remove those problem areas. And of course, at the end of the day, as a result, we get a better understandable code. We get something which is better understandable. It will make us better maintainable. And of course, it will make it better and easier for us to change it or scale it or add or remove functionalities. So refactoring, and that's why refactoring is important in all processes, and it is more important in agile process. As I said a few minutes ago, we have come a long way, and a number of IDEs actually allow us to do refactoring automatically for us, or they carry out the refactoring. Eclipse has inbuilt in it IntelliJ. There are some specific refactoring tools. All of them actually allow us to do these refactoring, but we need to test our applications to make sure that external behavior has not changed. Anybody has used any of these refactoring using Eclipse or any of the other IDEs? Anybody has seen
Yes.
this option?
Yes, doctor. I think I used refactor at Android Studio.
Android Studio, yes, Android Studio also has it. Absolutely, Android Studio also has it. Anybody else has tried to use it through Eclipse as part of your Java codes?
Yes, I am.
Yes, sir.
Yes, good, good. Which one? The extract method probably, or extract class, something like this, right? So there are quite a few of them actually, and but we still need to make sure that we ensure that at the end of the day our external behavior is correct. Now this leads to very, very important question. Okay, you can say, okay, I understand what refactoring is, and and so on and so forth, but why I should be doing refactoring? Now the reason we should be doing refactoring is, one reason is that we want to improve the software design. We want to improve the code in such a way that is easier for us to make changes. And of course, a code which is clearer, well structured, minimal ambiguity in it, clearly specified is something we're looking for. And when we write piece of codes, typically, in the beginning, especially, we don't tend to focus too much on making it a better structured one. And hence refactoring is required to help us better design and write the code. From my own industrial experience, to be honest, I have worked with a number of different programmers over the years. I have only come across one person, to be honest, only one person. He was my team leader, and in one of the projects, and that guy's code is probably the only code I have seen which anybody can go and understand it and read it and understand, and completely, without meeting him, can completely go on and extend it or change it. Apart from that, I have never come anybody code, to be honest, which is well structured from day one. And you will struggle to read your own code, isn't it? I'm pretty sure you guys must have experienced similar things, right? Even we struggle to read
Yes,
our own code after a couple of weeks, right?
all the time.
All the time. And in a large complex applications, when you have multiple team players, distributed teams, it's a nightmare unless you really focus on refactoring to make it more structured. As I said, to be honest, I have only come across one person's code. Was amazing. I still have some copies. Probably I'll see if I can bring it for you guys just as an example. So this is one thing, of course, and the reason you do this is basically, you try to write a piece of code which is easy to understand, right? Because at the end of the day, as Martin Flower said, we want to write a piece of code and we want to design our applications for human beings, because at the end of the day, no matter what, the compiler is able to understand is as long as you write it in the right way, as long as you do the right logic. But is it easy for a human being to understand your code and read it and comprehend it? It's a different ball game altogether. And refactoring, one of the aims or one of the reasons why we do refactoring is that we want the systems to be easy to be understandable, and especially for persons who are unfamiliar with your code. And it's a nightmare for us individually to read our own piece of code after a couple of weeks, let alone someone else's piece of code. So it's very, very important, that we do refactoring. This is another reason we're interested in doing refactoring. And of course, why we're interested in people reading someone else's code is because you need to use someone else's code. You need to maintain someone else's code. And, that's why we want it to be understandable. And this is the third one, which is a bit of a surprise, is this one. To find bugs. Well, a few minutes ago, I said, refactoring, you don't add new test cases. You don't, restructure or add new functionalities. So how we can, why we do refactoring? We do refactoring to find bugs. This is fascinating and interesting. What do you think? Why we have this? Because the first two are very obvious, isn't it? The first two are very obvious, isn't it? The Third one is a bit of a surprise.
Yes.
It's possible that a bug is generated because of perhaps a variable was named similar to a different variable, and in writing the code they were mistaken for each other.
Yeah, absolutely. Absolutely, Yusuf, spot on, spot on. Basically, you know, anybody else would like to make a comment because before I discuss?
It's like when you clean the house and you suddenly found something that you lost a long time ago.
Exactly, exactly. You know, exactly as Yusuf and Turki said. You know, when we write a piece of code and you know maybe you know we did the testing. Remember, we have done with the testing before we come to refactoring. We have a code which is working and we have tested it and it worked fine. Our test case is passed. And remember, we just discussed that a test case passes when your expected and actual outputs are the same ones, right? So this means the code is fine when we test it, but the moment we restructured it, you know, we unearthed some bugs which were being masked because the way it was written there. As for example, you know, by interchanging the same variables or similar variables interchangeably, and they happen to have the same value at a given time, for example, right? And as a result, we didn't figure it out and it passed. But actually, when you restructured it, you realize that you know it was incorrectly done. So everybody is clear about the third point because that's a bit of surprise. Right? I usually use this as an example in a testing course in the very beginning. Like for example, let's say you're trying to, it kind of fits here, but then it's a very simple case. But you know, let's say you're trying to take a square of a number, right? And you have a lot of lines. You do a variable storage and we say x plus x, right? So can we think of a test case where it will pass?
Two.
Two, right?
When
So
will
very
you pass
well,
two?
yeah, it will pass two, right? And then when we restructure it, probably you know we say, come on, there's some. Though it's not a a perfect example here, the variable ones is actually a better example, but just an example to help us understand that you know it's possible that sometimes our test cases may be passing, but once we restructure it, reorganize it, we unearth some problems. So this is an interesting reason we also do refactoring. Okay, so let me get rid of these ones. At the end of the day, basically, you know, what we're doing is always, to be honest, as a software engineer, always, whenever we start a new project, and I'm pretty sure you guys will also testify to this, whenever we start a new project, we always try our best to start with the right way. We try to develop it the right way, try to follow the principles, try to write a piece of code in a correct way. But over the period of time, due to many reasons, you know, because of lack of understanding of domain, maybe time limitations, we're trying to fix issues, different people are writing different parts of the application, we usually end up with a situation like this, isn't it? Despite our best intentions. And hence it's important to do refactoring to make it more easier to understand, make it more organized, make it more modular. Have you experienced this part? That you start with best intentions every time, but end up with a situation like this.
Yes.
Most of the time, to be honest, even in the industry, it
Yes.
happens. Most of the time, it happens in the industry as well. And hence, you need refactoring to basically restructure all of this stuff. So, this leads to another very interesting question, which is, should we refactor? And one of you can argue with me, to be honest, and say that, we have been taught different good design principles, architectural styles, solid principles, design patterns. If I apply all of them, this means, I'm coming up with a good design anyway. So if I have a good design, shouldn't that mean that I don't have to refactor, right? It's a valid question. Absolutely, it's a valid question that if I apply solid principles, I apply design patterns, organize my system in the best way. Why on earth I still need refactoring? Because shouldn't this lead to me to have a good code? Well, this is true that it will lead to a good code. It will lead to a well-structured code. But, in reality realistically, to be honest, it's extremely difficult to get the design right in the first time. It's almost impossible, no matter how experienced you are, because every time you have different applications, every time you have different domains. Original designs are always not often inadequate. They always have room for improvement. And more importantly, we as software engineers struggle with understanding the problem domains, understanding the user requirements. And as a result, yes, we apply good design principles, but yet we may not end up with a perfect code because of all of these or one of these reasons. And as a result, you still need to do refactoring. You still need to go on and restructure your code so that it's easy to understand, it's maintainable, it's scalable, so on and so forth. Everybody's clear about this point? That why, even despite applying good design principles, you may still need refactoring. Okay. So this leads to us to another very interesting question, which says, when should you refactor? What comes to your mind? When should we refactor?
Whenever we write some code, we refactor. If we see it as complex, like we refactor it.
True. So basically, we try to do it every time we write a piece of method or a class or whatever our responsibility is, right?
Yes.
Yes. Anybody else would like to make a comment? When should we do refactoring? Okay. Probably no one wants to comment on it, so maybe let's look at it. Basically, whenever you're going to add new functionality, right? Whenever you're going to write, as Saul said, write a new piece of code, you got to refactor it, because you got to refactor the existing code until you understand it. Because before you add a new functionality, you will have to understand the existing code, and for that to happen, if you have not already done the refactoring, probably it's a good thing to do is to refactor it to make it more organized. Or if it's part of your culture, then you basically write a piece of code and you refactor it so that it's better structured anyway, so that whenever new functionality needs to be added, it's just a straightforward process. And of course, you refactor the design to make it easy for make it more modular. You make it more better structured, so that adding new functionality or changing some functionality is much easier, rather than having everything in a one big method or having everything in a one big class and so on and so forth, because that is a nightmare anyway. Of course, as we said, saw a few minutes ago, to find bugs, we discussed why this could be happening, is that you are refactor to understand the code, and as a result, once you're going to understand the code, probably it will help you come up with better test cases. And once the moment you will be able to come up with the better test cases, you will be able to find bugs. But remember, keep in your mind, as I said in the earlier half of the lecture, you always gonna wear one of the hats. So when you're doing refactoring, you're not adding new test cases. You're not adding new functionalities, right? So this needs to be absolutely clear to us that yes, I should be doing refactoring Or when should I be doing refactoring? When I'm intending to add new functionalities or I'm intending to find more bugs. But it does not mean that I'm doing refactoring and as part of the refactoring, I'm adding new functionalities or I'm finding bugs. No, that's not the point. The point is you do refactoring so that when you're gonna wear the hat of the coder, it's easier for you. Or when you're gonna add the hat of the tester, it's easy for you to understand the code, hence come up with more test cases, better test cases, so on and so forth. Is this point clear? Because this is a very, very important point to us for us to understand. Because we don't want to be confused here that, in the earlier I said, as refactoring, you are only restructuring your code. You're not adding new functionalities. You're not adding new test cases. While here, one can be easily confused by saying, when should you refactor? When you're trying to add new functionality to find new bugs. Yes, but remember, you put the hat of the refactor to restructure the code, then you take away that hat and wear the hat of the coder for this part or wear the hat of the tester for this part. Everybody's on board with me on this point.
Yes.
Cool. And of course, for code reviews as well, this goes hand in hand anyway, that, when it's better structured, when it's better organized, it's easy for you to review the code, it's easy for you to suggest or identify problems in it and so on and so forth. Now, this leads to another very, very interesting question, which is basically says, when should you not refactor? Think when I should not be refactoring. Or when it is not recommended at all to do refactoring. At what time or what stage or stuff like that, what comes to mind?
Doctor?
Yes, Abdullah.
I think if there is a time constraint,
Yes.
the whole team has to be working on the project to submit on time. I think refactoring could be left for another sprint.
True, absolutely, absolutely, absolutely. Highly, highly recommended. Basically, when you're close to deadlines, don't try to refactor when you're close to deadlines. Because to be honest, I'm not sure how many of you guys have really, tried or observed this, that, when you try to refactor using one of the IDE inbuilt refactoring, for example, I have a piece of code, it's working fine, I'm close to a deadline, I'm actually struggling to meet the deadline to begin with. Eventually, after a lot of struggle and we are able to make a code which does meet the requirements and works fine. But if I try to refactor close to it, refactoring will reorganize this piece of code. As a result, I might introduce problems. I might face bugs. I might face compilation. I might face, some hidden issues, right? Or it will not be that straightforward that, once I refactor, it will always be compilable in a sense and so on and so forth. So it can easily break. That's what I'm trying to say. It can easily break and you are under such a pressure that, probably you will not be able to handle such a thing. So it's not recommended at all to do refactoring very close to your deadlines. You do refactoring, as Abdullah said, in the next sprint or in the next iteration. Of course, you also don't refactor your premature published interface. This is just for APIs, for example, or basically unstable code. You don't try to refactor your unstable code. Why is that? Why it's not recommended to refactor your unstable code?
I think because you don't understand it pretty well or very well.
Yes, you don't understand it. Mainly, basically, you have not yet implemented your functionality, right? This means you haven't done the task of the coder hat, for example, right? Or you haven't, for example, done the task of the tester hat yet. So it's still under evolution. It's still under changes, and since it's still being changed, what's the point of spending effort and energy of changing or restructuring something which is going to very soon change again? All right. So in other words, Basically, you know, unfinished refactoring is like a debt. You can live with it, but it's costly. It's not recommended to do refactoring when your things are not stable at all. Because if you're gonna, you have a piece of code which is not stable, you go on refactor it, it will cost you from a time, from effort, and everything. And then you're going to change this anyway because you have not done yet with your functionalities yet, right? So we should not be doing refactoring close to deadlines. We should not be doing refactoring with our unstable codes. So far, so good.
Yes.
Now, just to complete this discussion on basics or fundamentals of refactoring, refactoring at the end of the day, to be honest, is more like a team effort, right? And this needs to be inbuilt as a team culture, to be honest. And inshallah, you will see and experience this in your larger projects as you move along in your careers. Inshallah, when you do your design project, senior design project, and then you move into the industry, you know, you will realize that this needs to be refactoring needs to build in as a culture. Everybody has to buy it and has tried to apply it. Especially, for example, when myself or Dr. Shaib teaches senior design project, we follow agile approach. So we try to encourage and teach you guys and let you experience this refactoring culture, right? Because unless you believe in it and unless you follow it, you know, it's you know, you don't realize the benefit of it. So, and the reason is you need to incorporate this culture because nobody will get the code correct in the first way. It's very hard, even if you're very experienced. Yes, it will compile, you know, for sure it will compile because for you to come to refactoring, the program must be compiled, it must be doing its functionality. But whether it's a better structured one, that's a question. And nobody will get it structured correct in the first way, no matter how experienced you are. And, you know, nobody can write a piece of code, you know, a clear code in a very first way. And as I said, you know, to be honest, I have never come in through my own industrial experience anybody who writes a piece of code correct in the first way. The one example I quoted that his code was amazing, he used to do refactoring himself before he used to publish his teammates. He was our team leader, so you know, basically publish for us to use his piece of code. This is what happens in real life. You write a piece of code, your team members are developed depending on your piece of functionalities to use, and so on and so forth. So it needs to be a culture, and you know, of course, it helps you with your sound test case as well, because you need testing to to basically do refactoring, because once you're going to restructure your piece of code, you need to go on and test it to make sure that your external behavior has not changed, and hence you need to have a very good testing base. And again, this becomes, you know, they go hand in hand, and you know, you need to be probably run your systems daily, or build them and test them daily, and so on and so forth. So that's why you will see that in an agile process, it's a very, very crucial step, and it's like a culture there in an agile environment. Pair programming, yes, naturally also this also happens that, you know, uh, I was asked this question in the last section, previous section, where basically was that, do I refactor a piece of code for my only code, or can I do refactoring for someone else's code? And answer is basically you might end up refactoring someone else's code as well, because especially, for example, if you're doing a pair programming, an extreme programming, which is one agile approaches, you know, you work as a team and you basically write your own piece of code and you let someone else test your piece of code or refactor some piece of code. And it doesn't have to be even pair. You in a larger system application, larger team, sorry, you can might be end up doing refactoring for someone else's code. So you know, it's a culture. It's something, you know, it's a team effort. It cannot usually be done individually. It needs to be done as team. And for it to be work in a team, you know, yes, you need to know that the code bad smells and you need to know the solutions, but what's the process which works for you and your team also needs to be self discovered. That, you know, every team has to try what works for them when it comes to refactoring. You know, uh, they may say that when we are considering a change to a program, it should change the, you know, whenever basically, you look, say, okay, I'm going to change a program, so this means I need to, look at refactoring myself. Or if I'm going to make change to external behavior, I have to basically make sure that, how we going to handle this. The easier thing is basically break down your changes into smaller steps. Carry out these changes. Look at the problems which are happening. Try to eliminate these refactoring challenges you are trying to face, and over a period of time, once you're going to do it a couple of times, 2, 3, 4 times, you will be able to come up with a process which works for you as a team. Okay. Is this understandable? I mean, this is something you will experience, inshallah, because yes, knowing the bad smells, and which will inshallah be coming on Tuesday, code bad smells and fix of them, is one aspect. Doing it is another aspect. And for that to happen, you need to try to develop your own culture. You need to try it a few times, which works for you, at what stage it works for you. And after 2, 3 of these workable refactoring, you will be, inshallah, having a process which is basically something which works for your own, for your team, for your project. And with this, we conclude this half of the refactoring lecture. And we summarize that basically at the end of the day, as Martin Flower said, you refactor to change the internal structure of your code without having to change your external behaviors. And you do refactoring basically. So basically, as part of the refactoring hat or responsibility, you do not add new functionalities. You do not add new test cases. You only restructure them. And, the reason you should be doing refactoring is, or why you should be doing refactoring, because to make it easy for you to understand, to maybe make it more understandable and maintainable, to find even bugs. And why you should not be, or when you should not be doing refactoring, basically when your code is unstable, it's not yet finished, you're very close to deadlines, you're bound, you're prone to mistakes. You don't want to do that as well. And as a team effort, as a culture, this refactoring needs to be discovered, and you need to try 2, 3, 4 iterations, and then you will understand that how a refactoring is working for you as a team. And with this, inshallah, I think it's almost 10:50, so I'll take the attendance, stop the recording, inshallah, and we'll look at some of the code bad smells and their solutions, inshallah, on Tuesday, inshallah ta'ala.